Hello everyone and good day. For today's topic is we are going to talk about fluvial processes. Fluvia derived from a Latin word which means rivers. Fluvial processes. In geography and geology, fluvial processes are associated with rivers and streams that are deposits and landforms created by them. When the stream or rivers are associated with glaciers, ice sheets, or ice caps, the term glaciofluvial or fluvio-glacial is used. Fluvial processes is the sculpt, the landscape, eroding landforms, transporting sediment, and depositing it to create new landforms. This is in which the rivers, the streams, and the ponds is being made from of these processes. Human civilization and ecosystems are dependent on fluvial systems indeed. We are all familiar from the word stream, right? So a stream is a continuous body of surface water flowing within the bed and banks of a channel, whether it is a tiny creek or any enormous river. Streams and their valleys dissect the land in a multitude of patterns. However, those patterns exhibit important similarities, and so the study of individual streams can produce additional generalities to aid in our understanding of topographic development. Stream flow and overland flow. In fluvial processes, it is defined as those that involve running water, encompasses both the unchanneled downslope movement of surface water, which is called the overland flow, and the channeled movement of water along a valley bottom is called the stream flow. Valleys and interfluves. Valley it is that the position of the terrain in which a drainage system is clearly established. So, it includes the valley bottom that is partially or totally occupied by the channel of a stream, as well as the valley walls that rise above the valley bottom on both sides. The upper limit of a valley is not always readily apparent, but it can be clearly conceptualized as a lip or a rim at the top of the valley walls, above which is the drainage channels are either absent or indistinct. On the other hand, interfluve, derived from the latter word interfluve, derived from a Latin word inter, meaning between, and fluvia, meaning rivers. Interfluve is a higher land above the valley walls that separate adjacent valleys. So some interfluves consist of ridge tops or mountain crests with precipitous slopes, but others are simply broad and flattish. It divides between the drainage systems. And conceptually, all parts of the terrain not in a valley are part of an interfluve. We can see in this illustration there is the interfluves, the above or high level part of the land or the elevation, and we can see the blue lines over there as the water. We can see that the interfluves are the upper part of the land and the valleys is the lower part of the land. We can see the drainage divide written by imaginary line. So we can see here the gullies, which is made of the stream flow above, and the rills flowing down to the gullies, in which the interfluves is the high part level of the land and the rills begins to go into the stream flow downward to the stream of water. Drainage basins. The drainage basins, or the watershed of a particular stream, is all the area that contributes overland flow, stream flow, and groundwater to that stream. So in other words, the drainage basin consists of a stream valley's bottom, valley sides, and those portions of the surrounding interfluves that drain towards the valley. Conceptually, the drainage basin terminates at a drainage divide, which is the lines of separation between runoff that descends in the direction of one drainage basin and runoff that goes toward an adjacent basin. Stream orders. In every drainage basin, small streams come together to form successively larger ones, and small valleys join more extensive ones. So this relationship, although variable in detail, holds true for drainage basins of any size. This systematic characteristic makes it possible to recognize a natural organization within a watershed, and the concept of stream order has been devised to describe the arrangement. The picture above shows the example of stream orders. The branching component of a stream and its tributaries can be classified into a hierarchy of segments, ranging from smallest to largest. In this case, from 1 to 4, we can see at the picture above that there is indicated 1, which means this is the first part of the stream, down to the second, which is the other one part of the stream meets the other one, and then there is called the 2, and then the lower part it shows that it meets the other streams, and that's why it shows the third, and then later on all the streams meet together and the fourth streams or the mainstream drainage basins has occurred.
Good morning everyone. So we will be discussing floods and natural levee formation. An oxbow lake starts out as a curve or meander in a river. A lake forms as the river finds a different, shorter course. The meander becomes an oxbow lake along the side of the river. Oxbow lakes usually form in a flat, low-lying plains close to where the river empties into another body of water. So, as you can see here, the oxbow lake or the flow of water is being curved. So, curve niya siya hangtod sa curve, then na siya ma-form nga circle here in the part C. So as you can see, ang flow of river ani mo straight na po ni siya, and then kaning nasa kilid mo matawag ni siya nga oxbow lake, kay na abandon na ni siya kay wala naman ka tuig ang flow of river dire kay straight. Artificial inland lakes and other freshwater impoundments also contribute to coastal land loss by regulating river discharge and sediment load delivered to downstream deltas and beaches. Dams used to store potable water supplies, control floods, and provide recreation have a doubly negative effect on land loss by trapping sediment and eliminating peak flood discharges. So, ang isa ka example sa modifying rivers is dams, because they use dams to store water to prevent floods and to control the river flow and to avoid increased rapid erosion sa rivers and lakes. So this is one of the example of the river control, which is the flood control on the Mississippi River. The flood control plan is designed to control the project flood. It is a flood larger than the record flood of 1927. At Cairo, the project flood is estimated at 2,360,000 cubic feet per second. The project flood is 11% greater than the flood of 1927 at the mouth of the Arkansas River and 29% greater than the latitude of Red River Landing, amounting 3,030,000 CFS at that location about 60 miles below Natchez. So dams. Flow-through dams, also known as perforated dams, are constructed solely for the purpose of flood control and mitigation of flood risk in downstream communities and ecosystems. When water levels rise above the spillway, the dam restricts the amount flowing through the opening, decreasing peak flood flow. So, muna siya ang dams. So, gigamit na siya para mag-store sa water o makontrol na to ang flow sa river para di siya mag-cause of kanang floods and like mga erosion. Artificial levees. Levees can also be artificially created or reinforced. Artificial levees are usually built by piling soil, sand, or rocks on a cleared level surface. In places where the flow of a river is strong, levees may also be made of blocks of wood, plastic, or metal. So as you can see in the picture, so ang artificial levees is composed of piling of rocks, hollow blocks, or sand that would prevent the rapid erosion of the water. So gamit kini siya kay aron din na siya ingon nga maka form sa Oxbow River, which is the curve or the abandonment of the Oxbow River. The lower Mississippi River flows from the confluence of the Ohio River and Mississippi River at Cairo, Illinois, into the Gulf of Mexico. Mississippi River and Ohio River pathway ships have shaped and reshaped the landscapes through which they flow and where their sediment-laden tributary waters commingle at the confluence of the voyage to the Gulf of Mexico. After the Louisiana Purchase in 1803, the United States took control of the lower Mississippi River. During the Civil War, from 1861 to 1865, the Union and the Confederate forces battled for navigational control of the lower Mississippi River. The primary objective of this paper was to highlight how the strategic, navigational, and flooding control of the lower Mississippi River and geological and landscape resources were responsible for the successful economic development of this rich historical region of North America. So as you can see here, nasa ato ang picture karon is how they control the lower Mississippi River. Living on the flat plain. The flat plain is the flat land bordering rivers and lakes. As a naturally occurring feature of the landscape, a flood plain carries excess water when heavy rains that cause streams to overflow. Floodplains vary in size and shape. Small streams with steep, high banks have narrow floodplains. Other streams may have larger floodplains. No matter what shape or size, all floodplains have one thing in common: they flood. So pare-pareho na siyang small streams of kanang larger streams kay may excess ang water mo baha ra jud gyapon siya kay wala man siya laing kabot nga sa tubig. So as you can see here, wala rin siya kagawsan sa tubig kay naram siya sa plain. Floodplain restoration is the process of fully or partially restoring a river's floodplain to its original conditions before having been affected by the construction of levees. So as you can see kanina, levees nga pile of rocks and the draining of wetlands and marshes. So this is how they construct the floodplain restoration. So gihimo nila ning kaning restoration sa floodplain para ang tubig dili siya permanenteng gapundo sa plain, then ay kagawasan ang tubig. Stream terrace formation. A rejuvenating stream or river can erode vertically into the former floodplain to produce features called river terraces. If river erosion is rapid, then paired terraces are formed either side of the channel. So ang masabot ani ang paired terraces are formed when either side of the channel, ang erosion is rapid. So, ang ma-illustrate ani sa paired terraces is ano siya, kanang equal ang paghimo sa terraces. Unlike sa pikas kaning unpaired terraces og slow ang iyang erosion, kanang dili pod equal ang paghimo sa terraces. So as you can see, before the germination, wala pa siya ingon nga kagosa lang sa tubig. Well, after rejuvenation, na siya way para dali siya mo gos ang tubig. A river stream terrace is the bench or step that extends along the side of a valley and represents a former level of the floodplain of a stream or river. So kani sa higher part sa stream terrace, mao na siya former floodplain before nahimo ang river terrace or stream terrace. Entrenched meanders are those cut down with asymmetrical valley sides due to rapid downcutting. And in-ground meanders are those with a pronounced asymmetry of cross-section, which should normally develop under slower incision. So as you can see here, ang land kay kanang padayon siya nga nag-rise, while ang tubig or kaning river dire kay padayon siya nga nag-cut down padulong sa ilalom. Stream terrace form when streams carve down into their floodplains, leaving discontinuous remnants of older floodplain surfaces as step-like benches along the sides of the valley. Stream terraces are common throughout the western United States. So ano siya, before sa kaning sa stream terrace, ang paghima niya kay wala pa siya kaning increase erosion kaning sa figure A. Well, kaning sa figure B, mao na siya ang result sa increase erosion kay kaning sa terrace. So magkadugay na siya, makaubos na siya, cut down na siya sa ubos. Mong siya may stream terrace. Siya kanang process. Theories of landform development. Davis geomorphic cycle, also called geographic cycle or the cycle of erosion. Theory of the evolution of landforms. In this theory, first set forth by William M. Davis between 1884 and 1934. Landforms were assumed to change through time from youth to maturity and old age. So, ang pasabot ni William M. Davis kay each stage kay na siya specific characteristics, which is youth stage, maturity stage, and old age. Youth stage. The river flows along an uneven surface and there is an intensive bottom erosion. The gradients are steep and the erosion is rapid. Maturity stage. Rivers attains a profile of equilibrium. The landmass is fully dissected and well-integrated drainage system is developed. Ridges and valleys develop prominently. Floodplains develop and river meandering takes place. Old stage. The slope is gentle and velocity is low. The river loses most of its erosive power and flow in a sluggish manner. So here is the kanang example of the Davis geomorphic cycle. So as you can see here, ang sa young stage, ang young erosion is rapid and uneven surface pa ang nasa Well, sa mature, na tayo makita nga sense of equilibrium here. And the old is kanang hinay na ang iyang erosion kay nipis naman ang plain. Banks theory of crustal change and slope development. The theory of crustal change and slope development, this states that slopes assume various shapes as they erode. They argued that uplift immediately stimulates erosion and slope form is significantly influenced by the rate of uplift of other crustal deformation. So, as you can see here in the second cycle of erosion kay Kampeg, ang power of erosion here is kanang hinay hangtod sa pag-abot na sa waning development nagkakusog siya, pero ang common nila sa Davis cycle of erosion at in the end mo hinay gyapon ang yaang power of erosion.
So, stream channel. So, let me define first the stream channel. It is any long, narrow, sloping depression in the land that is shaped by the flowing of the water. So, channel flow. Channel flow is also a basic characteristic of stream flow. So, channel flow, one that distinguishes the overland flow. So, it is normally confined to channels, which gives a three-dimensional nature with a scope of considerable complexibility. So, turbulence or the turbulent flow. So, turbulence is the general downstream movement, and that is interrupted by the irregularities in the direction and the speed of the water. So, these irregularities produce momentary currents that can move in any direction, including the upward. So, turbulence is stream flow that is caused partly by the friction. So, the channel cross-section. So, the channel cross-section, it is a principal cause of flow irregularity is the retarding effect of the friction along the bottom and the sides of the channel. So, it causes the water to move most slowly and also the fastest in the center of the stream. So, the amount of friction is determined by the width and depth of the channel and the roughness of its surface. So, as you can see at the picture, the friction between the stream bank and the liquid surfaces causes a stream to flow fastest in the middle and at the surface. So, the arrow lengths indicate the water speed is the greatest at the surface, and where the water is farthest from any solid surfaces and least at the bottom where the water drags along the stream bed. So, there are 4 stream channels patterns. So, first pattern is the straight channel. So, straight channel are the short and uncommon and also usually indicative of strong control by the underlying geologic structure. So, a straight channel does not necessarily means that it's straight flow. However, a line running in the direction of the water and indicating the deepest parts of the channel. So, it is called the thalweg. So, it is rarely follow a straight path midway between the stream banks. So, rather, it wanders back and forth across the channel. So, opposite the place where the thalweg approaches one bank, a deposit of alluvium is likely to be found. The second stream channel pattern is the sinuous channel. So, sinuous channel are much more common than straight one. So, they are winding channels and are found in almost every type of the topographic setting. So, the third one is the meandering channel. So, as you can see at the picture above, so that is meandering channel, which exhibit an extraordinary intricate pattern of smooth curves in which the stream follows a serpentine course, so twisting and contorting and turning back on itself, so forming tightly curved loops and then abandoning them, so cutting a new different and equally twisting course. So, meandering generally occurs when the land is flat and the gradient is low, especially when the most of the rock being transported by the stream is fine-grained suspended load. So, a meander shifts its location almost continuously. And lastly, the braided channels. So, the braided channels consisted of multiplicity of interwoven and interconnected channels separated by low bars or island of sand, gravel, and other loose debris. So, these braided channels or braiding often takes place when a very flat stream channel has a heavy load of sediment, such as the coarse-grained bed load supplied by the glaciers to a meltwater stream. So, and in regions with prominent dry season and periods of low stream discharge, such as the common in arid environments. So, structural relationships. So, consequent and subsequent streams, the simplest and most common relationship between underlying structure and channel development is one in which the stream follows the initial slope of the land. So, consequent stream is normally the first to develop on newly uplifted land, and many streams remain consequent throughout their evolutionary development. So, subsequent streams develop along zones of structural weakness. So, as you can see at the picture above, a consequent stream follows the initial slope of the land, whereas a subsequent stream flows along the structural weaknesses. Stream drainage pattern. So, under this is dendritic pattern. So, this is the most common drainage pattern over the world, and it is formed as tree-like branching one called a dendritic drainage pattern. So, this pattern resembles branches on a tree or veins on a leaf. So, dendritic comes from the Greek word dendron, which means a tree. So, you can see the dendritic pattern in the picture above. So, in the stream drainage pattern again is the trellis pattern. So, this pattern developed as a response to underlying structure control. In this case, alternating bands of tilted hard and soft strata. So, with long parallel streams linked by short right-angled segment. So, followed by the annular pattern. So, annular pattern is more complex. It is an annular drainage pattern. This is ring-shaped drainage pattern that can develop either on a dome or in a basin where dissection has exposed alternating concentric bands of tilted, hard, and soft rock. So, annular comes from the Latin word annularis, meaning a ring. So, the picture is shown above. So, at radial pattern. Radial drainage pattern is usually found when streams descend from sort of concentric uplift, such as an isolated volcano. So, centripetal pattern. A centripetal drainage pattern is essentially the opposite of the radial one. It is usually associated with streams converging in a basin. So, the example is shown above. So, delta formation. So, delta formation is a wetlands that form as rivers empty their water and sediment into another body of water, such as the ocean, lake, or another river. Although very uncommon, delta can also empty into the land. So, deposition in valleys. So, during high water periods when flow is vast and voluminous, the stream scores its bed by detaching the particles from it and shifting most or all sediment downstream. So, and during the low water periods, particularly after a period of flood flow, the flow is slowed and sediment is more likely to settle to the bottom, which results in filling of the channel. So, floodplains. Floodplains is the most important assemblage of fluvial landforms. So, it is the most prominent depositional landscape. It is a low-lying, nearly flat alluvial valley floor that is periodically inundated with flood water. So, floodplains are frequently formed where a meandering stream flows across a wide, nearly level valley floor. A floodplain landform. So, floodplain landforms, it is the frequent shifting of stream meanders produces an increasingly broader, flattish valley floor, largely or the common or the completely covered with deposits of alluvium left by the periodic floods at any given time. So a stream is likely to occupy only a small portion of the flatland, although during the periods of the flood flow the entire floor may be flooded, but for this reason the valley bottom is properly termed a floodplain. So, cut-off meanders. So, this is the most conspicuous floodplain, and it is often meandering channels. So, cut-off meanders is a meandering river swings back and forth in ever expanding lopes. Eventually, the radius of a lope reaches about 2.5 times the stream with the lope stops growing. So, as you can see at the picture above, that is the example of the cut-off meanders. So, as you can see at the figure 16 figure above, the formation of the cut-off meander on a floodplain as the river cuts across the narrow neck of a meander, the river band becomes an oxbow lake. So, when becomes an oxbow swamp, which become a meander scar. So, the natural levee. So, as the stream overflows at the flood time, the current as it leaves the normal channel is abruptly slowed by the friction with the floodplain surface. So, this slowdown causes the principal deposition to take place along the margins of the main channel, producing the natural levee. That comes from the old French word meaning the act of racing. So, the act of racing on each side of the stream. So, the natural levee merge outwardly and almost imperceptibly with the less well-drained and lower portion of the floodplain, generally referred to as the back swamps. As you can see at the picture above, that is the example of the natural levee. So, that typical landform is a floodplain. So, natural levees build up from the alluvium deposited along the sides of a stream during the floods.